Example 2. Below is a graph modeling the amount of sugar required to make Grandma's special chocolate chip cookies. Now notice this is a different problem. This time we're talking about sugar instead of flour. And here's the graph they've given us. Our first question says to record the coordinates from the graph, what do these ordered pairs represent? I'm going to go through on my graph and make these a little bit bigger so they're a little easier to see on the camera. All right, we're going to list out each of these coordinate pairs and then we're going to describe what it means. So our first one is 0, 0, which means 0 cups of sugar for 0 dozen cookies. 0 cups sugar makes 0 dozen cookies. Okay, our next point, so I notice these are counting by 1, so 1, 2, and then up 1, 2, 3, 2, 3. So this would mean 2 cups of sugar makes 3 dozen cookies. Makes 3 dozen cookies. All right, our next point, so there's 3. Well, let's see, 1, 2, 3, 4, and that goes up 5, 6. So our point is 4, 6, which means 4 cups of sugar makes 6 dozen cookies. Okay, let's come back down here. So here's our next point. So there's 5, 6, 7, 8, and then there's 5, 10, 11, 12. So 8, 12, which means 8 cups sugar makes 12 dozen cookies. Okay, our next point is right here. So see, 8, 10, 11, 12, and then there's 15, 16, 17, 18. So 12, 18. $12 cups sugar makes 18 dozen cookies. And our last point, way over here, let's see, 16, there's 20, 21, 22, 23, 24. So 16, 24. I have to squeeze it down here on the bottom. So 16 cups sugar makes 24 dozen cookies. All right, Grandma has 1 remaining cup of sugar. How many dozen cookies will she be able to make? Write the coordinates of this point. All right, so when we're talking about when she has 1 cup of sugar left, so we're going to be finding that unit rate. So we want this to be our 1. So we're comparing cookies to sugar because we want 1 cup of sugar. So we could use any of our points. So these are all X's and these are all Y's. I'm just going to use this top one. So I'm going to do my Y value, or my 3 dozen cookies, to 2 cups of sugar, or my X value. So when Grandma has 1 remaining cup of sugar, she can make 3 halves, or 1.5 dozen cookies. Now if we're talking about this point on the graph, so we've looked at several points here, that means if we go over to 1, this is going to cross at 3 halves. So that point would be 1, and 3/2. This point is special when we talk about proportional relationships, because anytime we want to find the rate of a proportional relationship or a unit rate, we can find where this x is 1, and whatever this y value is, that will be our unit rate. Now, we can do that because if we think about this as our x, that means this is 1. So whatever that y value is, if it's over 1, that's our unit rate. You may see this, this point written in the form 1 comma r, meaning that this is your unit rate. So if they talk about where that point is on the graph, whatever that y value is when x is 1, then that's your unit rate. How many dozen cookies can Grandma make if she has no sugar? Can you graph this on the coordinate plane provided above, and what do we call this point? So if Grandma has 0 cups sugar, is she going to be able to make any cookies? And that is no. So 0 cups of sugar would be 0 dozen cookies. And that would be a very, very sad day if Grandma didn't have any sugar to make cookies. So when we graph this point, get my graph back out. When we graph that, we already did graph that point, that 0 cups of sugar makes 0 dozen cookies. So this point we're talking about right now is at 0, 0. So this would, oh, I should capitalize that. I'm going to write this as a sentence, sorry. This would be the point 0, 0. And we get this name, this point has a special name, and this is called the origin. The point 0, 0 is called, it's a horrible E, sorry, called the origin, meaning that's where it starts at.